What we're looking at today is systems of linear equations. So if you remember doing problems like this here, where we're trying to find the point where they intersect, because we could do it by graphing, substitution, or elimination, are the three main ways. And y'all went over this in Algebra 1, of finding that point of intersection, where they cross, where they intersect. And we do have the case where they don't cross, because they could be parallel, so there's no solution for those. Or, because that's the main way that's like they're not going to be equal, or they could be all real. And if it's an all real solution, it means it's really, for these here, it works out that they were the same line. We got a true statement. But what we're doing today is not going to be solving two variable systems of equations. We're going to be working with three variable systems of equations. And there are ways to do this with substitution, and with graphing, we can technically graph it, but again, x, y, z, we're looking at a three-dimensional plane. Each one of these equations represents a plane. So if you remember geometry of plane, we can kind of picture it as a rectangular shape. And what we're doing is we're looking for a point or solution set that will make all these three true, where all three of these planes intersect or cross. That's what we're looking for in this here. Now, where A, B, and C are not all zero. Well, hopefully, because in this equation here, if A, B, and C are all zero, I mean, any one that actually has a variable is going to be zero, so it doesn't tell us anything. So they have to be something other than zero. So questions on this so far? Now, I know the pictures on the paper are very hard to see. Yes, for y'all's note sheets. Now, there's three different setups that we can have, and this here is one of them. Yep. Yep. Yep.
Hey, I saved you from getting stung.
Yeah, I've been stung by those before. It stings for a little bit, and as long as you're not allergic, they're not too bad.
I got it off of you.
Yeah, last hour was. Yep. They were freaking out trying to jump up and slap him. There's at least one of those trapped in one of the lights. He's not alive anymore, but. Now, the one type of solution that we can have for this is this one here. We have a solution. We have 1 point. So if all three cross at a point, that is our solution. So we'd be looking at a point x, y, z. So something like 2, 4, -3. So that would be the point where they cross. That would be the solution. So the main thing is you don't have to write that down. I just pick numbers out of the air. They kind of give us an idea. It's just a point. Now the next type is this one here, infinitely many. All the points on this line represent the solution. And for the most part here, when we talk about this here, we're not going to delve too deep into this. We'll see. But what this is all the points on that line represent a solution for this here. So it's represented by this equation. There's infinitely many because a line extends in two directions forever. So any point on that line would represent this equation. And normally when we get this solution, x, y, or z, one of them is going to simplify out. And normally when we talk about this, we call it a. We call that variable a. And the other two, we can write it in terms of a. So we could say 2a plus 1 or 6a minus 3. And again, this is just an example. But any a, I could plug in an a and generate a solution set like the one I wrote for the previous one that will work for this. And we could plug in any value of a. Now, most likely we won't get too far into this because it's essentially saying that there's an infinite number of solutions. It's all real solutions, infinite many solutions. And this here, these equations define what those solutions are. I can plug in any value A and create a solution that would work. That's what this is here. And the last one's no solution. Well, the one of these three of these that makes most sense is this one here. Because all three planes are parallel, they don't cross, they never intersect. There is no solution. But if we look at the other two here, for any of these planes, only two of them cross at any given point. There's only two. We need all three. For us to have a solution, we need a point or line where all three cross, where all three have a point of intersection. And in all of these three, we don't have that. That's a no solution. Questions on this here? Now, on the next page, we have this list here. Now, these are the steps that we would need to follow to be able to solve a three-variable system of equation algebraically. Now, I think their wording's pretty good, but I'm going to write out some steps hopefully to make it a little bit clearer. Probably when I write them out, it's not, but once we start doing them, it'll make more sense. But the first main step is to rewrite the linear system in three variables as a linear system in two variables by using substitution or elimination method. Second step, solve the new linear system for both of its variables. Step 3, substitute the new values into step 2 into the original equation and solve for the remaining ones. Okay. I'm going to give us some different steps. It might be one or two more, but it'll make a little more sense. Now, when you obtain a false equation, 0 equals 1. Is 0 ever equal to 1? No, not in our base 10 number system. We have to start getting into other number systems for that to work. But even then, that's not a true statement. If we get a false statement in any of the steps, the system has no solution. If we're working through this and at some point we get a false statement, it doesn't have to be 0 equals 1. It could be 0 equals -7 or 2 equals 4. If it is no solution. Because what's that saying? Because again, when we did two variable systems of equations, if you ever got that there, it's saying that the two lines are parallel. They don't cross, they never intersect. And especially when we do elimination, we're trying to find that point of intersection. And whenever the variables cancel out completely, it means they're parallel. They don't cross. Now, if we get a true statement, I feel like they could have phrased that better. When you do not obtain a false equation, that's a double negative. But obtain an identity such as 0 equals 0. That's always true. Then the system has infinitely many solutions. Now, again, it doesn't say at any step, in any of the steps, this is the case. In any step where we get a false statement, it is no solution, we are done. If we get a true statement at one of the steps before the end, we need to go on and finish. Because it could work out on one of the steps we do get a true statement 0 equals 0. We do the other one, we get a false statement. Does that make sense? Because essentially what I'm explaining or describing is that almost those two planes, so the two equations are essentially the same plane. And the third one is parallel down here. So the first two are the same, but the third one's off on its own. So it's no solution. Because again, we need all three to intersect. Because as soon as we see, let's go back one, like this here, the two that are flat, that gives us a false statement. They don't intersect. Well, if those don't intersect, there's no way we can have a solution because we need all three. That's why we can stop with the no solution right as soon as we get it. But the infinitely many, we have to take it all the way to the end. Questions on this here? Okay. I'm going to write the steps down for us. So step number 1. We need to pick a variable to I would, but this is kind of my thinking. This is how I would describe these steps, because for the most part, I don't think, I mean, for some, the steps that we just had made perfect sense. But how many of y'all would say that those steps were confusing and were a little bit clunky? Yes. So I'm going to rewrite it in a way that would make more sense to us. So the first thing we want to do is to pick a variable to eliminate. And for these here, we're mainly going to focus on elimination. So we're going to pick one of the three variables to eliminate and an equation to eliminate it with. Because what our first goal is to take, because again, we're going to have three equations with three variables, and we want to take it from that down to two equations with two. Now, the steps that we have for this here are very focused on three equations with three variables. Three equations with three variables. And yes, we can have systems that have three variables, but we only have two equations. We can have that set up. And if we do, we're talking about an infinite number of solutions, because there's not going to be a third one to define it down to a point. So, okay, so we're going to pick an equation, variable to eliminate and an equation to eliminate it with. Step 2. Eliminate the variable, or eliminate a variable, because we're going to eliminate the one we chose. That's the main second step. All right. Now for step 3, we're going to repeat steps 1 and 2, but this time we don't have to have an equation. We don't have to pick an equation to eliminate. We're mainly just picking a variable and eliminating it. So the third step, we don't need to do anything with the equation again, but we're picking a variable and eliminating it. And step number 4. Solve for the variable then solve backwards. Solve for the variable and then solve backwards. And the solve backwards will make sense here in a minute. It'll make more sense once we get there. Because again, there's one of 3 answers that we're going to get from this here. We're either going to get a value for x, y, z, the 3 variables, whatever we have, because they'll sometimes use UST, JKL. I mean, we can use any 3 letters. But we're going to start off with 3 equations with 3 variables. So we're going to have possibly a value for each variable, all real solutions or no solutions. So we have 1 of 3. So we ready for this here? I mean, as ready as we're going to be. So this is the first one we're going to look at here. So we have 3 equations with 3 variables, yes? Now the first main step is to pick a variable and an equation to eliminate it out with. Now we look at the variables, well there's 3 of them. We want to pick one that it's going to be easy to turn it into the other 2. So if we looked at x's, we have these 3 x's here, yes? Well, can I turn 2x into 4x pretty easily? Yeah, we can do what? We multiply it by? Can I turn 2x into 6x pretty easily? Yeah, we can multiply it by 3. That's easy to do. If we looked at the y's, and again, I always look at the smallest one to make it bigger. We want to make them increase. If we're changing them, we don't want to go down. It's better to multiply than it is to divide. It's easy, sorry. Let me rephrase that. It's easier to multiply a number up than it is to try to divide it down. Because if I want to turn y into 2y, I just need to multiply it by 2. If I want to turn y into 3y, I just need to multiply it by 3. So y or x is pretty easy to eliminate, to get them to be the same and remove them. If you remember back to doing two variables elimination, we tried to get one to have the same number, then add or subtract to get it to go away. That's the same thing we're doing here. Now with z, is it easy to turn 3z into 5z or 4z? No. And that's the same thing is true with 4 or 5z. Z's don't work well here because it's not easy to turn one into the other. So if we're going to eliminate, we want to eliminate y or x. We want to do one of those. Which one do y'all want to do? We can do the y's. So we picked our variable that we're going to eliminate, yes? So that's the first half of step 1. Now we also need to pick an eliminator equation. Now when y'all did this with two variables, we didn't have to pick an eliminator equation. Because we just had the two, we got the y values to be the same and went from there. Because it took it from two equations with two variables to one equation with 1. So it went from 2 to 1. But we don't have 2 with two variables, we have 3 with 3. So what we're going to do is we're going to use one of these equations to get one of the variables to go away. So if we're picking y, which equation has the easiest y to work with? The third one, yes? Because what's the number in front of y? 1, negative 1, but 1, yes? Because it's easy to turn 1 into 2, and it's easy to turn 1 into 3, yes? So that's the equation we're looking for. This here, the bottom one, is our eliminator equation. So the eliminator equation is the one we're going to use to eliminate that first variable out, to get rid of it. Does that make sense? Now once we pick it and we use it to eliminate the first variable, we are not going to use it till the very end, or we don't have to really. We're not going to use it in the next few steps. It's just used to remove that variable. Does that make sense? Okay, now you might need to write a little bit small because I realized, I think for every year, that I did not give you guys enough space to write massive or big because you only got so much room right there, all right? Now, we will have some side scratch work that we'll need to do. Is again, we need to get this y value to be the same as the other two, yes? So what I would suggest doing, I'm going to have to move stuff around because my space is not as, I don't have as much space as y'all do. I would start off by first, in the center, writing our two other equations. And we can put a little bit of a line. So this here is where we're going to do our main kind of elimination step first. Now out to the sides, we'll do kind of the scratch work to get the y values to be the same. Now, I'm going to do something that y'all definitely can't do. Just move stuff over on the page. That's the nice thing about technology. Now, we'll start off with the one on the left. So our 4x plus 2y plus 3z equals 12. Now, there's different ways that books will go about talking about this and doing this. The main way I look at it and focus on it is, what do I need to do to y to get it to be 2y? I mainly focus on the number. By? Or just 1, yeah. Multiply by 2. Some books will talk about the sign in front of it and that we want to try to keep them the same. My main focus is the number. Because what do we need to multiply 1 by to get 2? Well, we need to multiply by 2. So we're going to take the other equation, 6x minus y plus 4z equals 3. And we're going to multiply the whole thing, every part of it, by 2. Now 2 times 6x is 12x minus 2 times negative y is negative. 2 times 4z is 3 times 2 is. Questions on this here? And we'll put it under that original one. And again, with any of these calculations, I use a calculator. If you don't feel 100% comfortable with it, doing any of these here, use a calculator. There is nothing wrong with using the calculator. All right? I think it's, if you need it, use it. Because there's nothing wrong with using it if you have it. All right? I think it's the same for like softball, for the catchers wearing the, or softball or baseball wearing the, for the supports. I don't know what they're called, the little, yeah, the behind your legs so that you're, yep, the spacer, so you're not just having to sit there crouched for forever. Or if you do cow or what is it, riding, bull riding, wearing a flat jacket, wearing those, if you have them, use them. There's nothing against it, all right? Because it helps you get, for this here, using the calculator helps you get it right. Might as well use it. Knee savers, yep. So we have this here. Question on this so far? Nothing too bad? All right. If we have this here, I'm going to erase this and try to erase this. There we go. And I'm going to move all this over. Because most likely you wrote the one on the left-hand side, yes? So now we need the y's on the right-hand side to be the same. So this time, instead of multiplying by 2, we're going to multiply by what? 3. No. Okay, good. So this time we need to multiply both sides by 3, because we need the y's to be 3. We need them both to be 3, because that's what we're trying to do. We're trying to get the y to cancel out in both. We'll do the same thing. We'll distribute. 3 times 6x is minus 3 times y is 3 times 4 is 12z is equal to negative 3 times 3 is negative 9. So we get this here. And we can put it under the other equation. 18x minus 3y plus 12z equals negative 9. And we have these two equations here. Pretty good with this so far. So, I mean, on a whole, all the steps that we're doing to get here aren't that bad. Would we agree with that? Yeah. There's a lot of steps so far, and we're not, because we haven't eliminated the first one, but that's the main thing with Algebra 2. It's just lots of little steps. I don't like using the word easy, but kind of easy little steps that we're doing one after another. Now, looking at this here, we want the y's to cancel out, yes? We want them to become 0, yes? So with the first one here, 2y and negative 2y, if we add, should we add those together or subtract them? So what is 2 minus negative 2? 2 minus negative 2 is 4. Negative 2 minus 2 is negative 2, isn't it? So we wouldn't subtract, we would add. 2 plus negative 2 is 0. Positive, yep. Now, this is one thing that helps us check. Because if we're like, okay, subtract, actually do the subtraction across the board, across each one. Because as we just saw, okay, even plugging in the calculator just to make sure, okay, 2 minus negative 2 did not give us 0. Okay, so I don't need to subtract, I need to add. Now, and again, it's good to make sure and check that we do it. Because, okay, I caught that. Okay, it's not subtracting, it is adding. I can fix it. If we'd have just assumed, okay, it is 0 because we subtracted and marked the y's out, we would have gotten the wrong answer. Does that make sense? Because it's not actually 0, we did the wrong operation. So now when we come through, 4x plus 12x is 16x. And as we just saw, 2 plus negative 2, 2 minus 2 is 0. It is indeed 0. 3 plus 8z plus 11z. 12 plus 6 is, let's make sure. I think it should be negative 6. That's 6. It should be negative 6. I'm glad I caught that. Yep. So it should be positive 6. So again, I think I said that during the first, for those of you who came in for homecoming, or not homecoming, open house, or the first few days. If something doesn't seem right, ask. It was like just right there. I dropped a negative. It's going to change the answer. Any other questions on this here? Now let's look at the other one. Would we need to subtract or add? Because we have negative 3 and negative 3 for the y's, yes? So negative 3 minus negative 3 does give us 0. Negative 3 plus negative 3 gives us negative 6. So here we would subtract. The way I remember it, if the signs are the same, we subtract. If the signs are opposite, we add. Is how I remember it. But also, as we saw with both of these here, we can try one. We could try subtraction or addition and see negative 3 minus 3. Does it give a 0? If it does, awesome. If it doesn't, we can change it from subtraction to addition. Try it again. Does it give a 0? Yes. That's the one we use. Because here, when we go through, 2 minus 18. Negative 3 minus negative 3. Well, the other negative makes positive. Negative 3 plus 3 is. So those do indeed cancel out. 5 minus 12 is negative 7z is equal to 7 minus negative 9. Well, the negative and negative make plus, giving us 2, positive 2. And again, if some of the negatives, all of that get really gets confusing, type it in the calculator. Type it in exactly as you see it. Because the calculator has no issue doing negative 7 minus negative 9. It'll perform the operations for us. If we have the resource, we might as well use it. So we've taken it from 3 equations with 2 variables to 2 equations with 2 variables, yes? Okay. Now the third says that takes us through steps 1 and 2, yes? Step 3 is what? Repeat steps 1 and 2. We don't have to pick another equation, but we have 2 equations with 2 variables. So I just need to pick a variable to eliminate. I think we're kind of unanimous on which one, yes? X. Because the number in front of X are the, so it's a good one to start with, or to use. And since we don't have to change anything, we can just put 16x plus 11z equals 6 over negative 16x minus 7z equals 2. Bless you. Bless you. Now, would we add or subtract? Because the signs are opposite. Because 16 plus negative 16 is the same as 16 minus 16, which is indeed 0. (11 plus negative 7). 11 minus 7 is 4. Yep. Okay. So we've gone from three equations with 3 variables to 2 equations with 2 variables. Now we have 1 equation with, what can we do next? By? It takes a while. We're not quite done because, well, how many variables did we start with? And the last step was to solve for the last variable, yes? And then solve backwards. Now, I say solve backwards. I think the note said and then solve for the remaining variable, so on and so forth. I like solve backwards because what we're going to do is we're just going back up the page because we're going backwards through the problem. Because the first spot that we're going to stop at is right here. Because I do have these 2 equations, yes? They're in the version of x and z, yes? Do I know one of those 2? Yes, so which one do we want to use? Doesn't matter. You want the one where they're both positive? Yeah, so we can use this. I'll take that color back. If we can say 16x plus 11 times 2 is equal to 6. So now we just need to solve for x. 11 times 2 is? Then we would do one step first. Yes, minus 22. Yes? And then? Yes. So we've got 2 out of the 3, yes? So we need to keep going back up the page. So do we have all this here? Okay, I'm going to scroll up and then hit this button here. And write these out to the side. So technically we have 5 equations to look at because we have the original 3 we got to start with, yes? Then we created 2 more to eliminate y out. So we have 5 technically that we can work with. I wouldn't even put the 2 that we made to eliminate y into the equation. I would just pick between one of these 3 here. So I'll let y'all pick. Which one do we want? The top one? So we'll take it and say 4 times x's value, -1, plus 2y, because we don't know what y is yet, plus 3 times 2 is equal to 12. We can do -4 plus 6, yes? Or 6 minus 4. Two y is equal to. Divide both sides by 2. So y is equal to 5, which gives us the solution point. So you can write this down to the bottom or over to the side of -1, 5, 2. And this right here is the solution, the ordered triplet of this here. And that's it. Yes, and that's what a lot of what Algebra 2 is going to be. And I said this, well, you weren't here for the first day, and I'll say it a good bit throughout the year as long as I remember to say it. A lot of Algebra 2 is, again, it gets the rap that this is the hardest class you're going to take while you're in high school. But this here is a lot of it. It's a lot of little easy steps that we're doing all the way through. Because if we try to tackle it as a whole, it can be overwhelming, it can be complicated. But if we take it step by step, all the way through, take it little chunks at a time, it's not that bad. And again, remembering the order of all the steps, that's what can make it challenging. Because a lot of this is just a lot of little easy steps one after the other. One of the other things I would suggest, or not suggest, but you could find helpful, is if you notice a lot of the time through these here, I'm asking questions. If you find those helpful, I would jot them down on the side to where you can start asking yourself those questions as you work through the problems. Like, what are we doing next? What do I need to find? To where when you're working them on your own, if you start prompting yourself those, then you can help yourself through the problems. But again, I'm not going to make you do that.